We are discussing the IIT-JAM 2020 Modern Physics questions. Here we are having 1 marks MCQ problem. This problem is related to photoelectric effect, and in a photoelectric effect experiment, a monochromatic light source emitting photon with energy greater than the work function of the metal under test is used. If the power of light source is double, which one of the following intensity is correct? Now, according to question, E is greater than h nu naught, where W is equals to h nu naught is the work function of the metal. Further, there are two kind of problems. One is stopping potential and second is regarding the number of photoelectrons. So there are two cases. Case first, stopping potential. So stopping potential is defined as EVS and is equals to kinetic energy equals to h nu minus h nu naught. If power of the light source is doubled, then there is no effect on the frequency of incident light and work function. Hence, the stopping potential remains same. Now, case 2. With regards to number of electrons. Intensity I is related to number of electrons. So, I would be writing this statement here. So, I is equals to P. Intensity is defined as or is having the same unit as that of power is equals to energy by area. Now, according to question, P is doubled. That means I is doubled, which means number of photoelectron should be doubled, must be doubled. But if we check the option, here photoelectrons remains the same. That cannot be the case since power increase, intensity increase in intensity would result In higher photocurrent, that means higher number of emitted photoelectron. So that cannot be option, that cannot be option. Is topic potential double, that cannot happen. So option B is our correct answer. Consider the motion of a quantum particle of mass m and energy E under the influence of a step potential of height V0. If R don't denote the reflection coefficient, which one of the following is true? Let us check out what is the height of the energy of particle with respect to height. Now we just focus upon two things. Here, if I take it this as greater than V, E is equals to 4 by 3 V0 is greater than height of the V0, that is case 1. E is equals to V0 by 2 less than height of the barrier. These are the two cases. So when the particle is having height of the energy greater than the height of the barrier, ठीक है, case 1 if I am writing here, when E is greater than V0, then R is not equals to 1, as most of the particle is transmitted through the barrier. Now case second, when E is less than V. Now writing Schrödinger equation in this region, let us discuss case 1 again using Schrödinger equation. So case 1, region second, now this is first region, this is second region. In the region second, Schrödinger equation H psi is equals to E psi implies minus H square by twice M del square psi by del X square plus V0 psi is equals to E psi. That means del square psi by del X square plus 2M E minus V0 by H cross square psi is equals to 0, or we can write it del square psi by del X square plus alpha square psi is equals to 0, where alpha square is defined as 2m by H cross square E minus V0. Solution of the particle in this region would be psi would be C e की power I alpha x plus D e की power minus I alpha x. So taking limit psi limit x tends to minus infinity, psi of x must be 0 implies D is equals to 0. That means wave function psi in region second x greater than 0 is psi of x to C e की power I alpha x. Now transmission coefficient. Or I would be making one change. Take this term as beta. Now, in Schrödinger region first. Schrödinger equation is del square psi is equals to E psi is equals to minus del square psi h square by twice m del square psi by del x square is equals to E psi is equals to implies del square psi by del x square plus 2m by h cross square psi equals to 0. X less than 0. Now we are assuming this term as alpha square. So del square psi by del x square plus alpha square psi is equals to 0. Its solution would be psi a e की power I alpha x plus b e की power minus I alpha x, where alpha square is 2m h cross square. Here e would be there, so e. Now, so J incident is a e की power I alpha x. J transmitted is c e की power I beta x. Transmission coefficient is J transmitted by J incident. Now, where J is probability current density, and defined as h cross by twice mi psi minus psi gradient divergence or gradient of psi transpose, psi star minus psi star gradient of psi. So for J trans, h cross by 2 mi would be mod c square. The formula here, I am making correction into the formula, that is like this one. Mod c square I beta plus mod c square I beta. So we would be having equals to h cross by m beta mod c square. Similarly, J incident would be h cross alpha m mod a square. So for case 1, when E, T will be h cross beta by m mod c square divided by h cross alpha by m mod a square. So some of the particles are penetrating inside the barrier. So R must be less than 1. R cannot be equals to 1. So these options were, in this case, it is not possible. Further, R is not 0 either. So in the case 1, r is less than 1, but r does not have 0 or 1. Now in case second, when e is less than the height of barrier, Schrödinger or x greater than 0. Schrödinger equation in this region is h psi is equals to e psi implies minus h square by twice m del x square psi plus v0 psi equals to e psi. So here that equation del square by del x square minus twice m h cross square v0 minus e of psi is equals to 0 implies psi 2x equals to c e to the power minus beta x plus d e to the power positive beta x. Now limiting case x tends to minus infinity, psi of x must be 0 implies d is equals to 0. So wave function psi of x in region x greater than 0 is psi of x is equals to c e to the power minus beta x. Now J trans for this term would be 0 as psi 2x star would be same as e to the power minus beta x. So since J trans is 0, so T in this case would be J trans divided by J incident equals to 0. So T 0 that, but we know R plus T is equals to 1 implies R is equals to 1. So for E less than V, R is 1, T is 0. So which option is correct? Option C is correct. The normalized ground state wave function of one-dimension harmonic oscillator with the four constants k and mass m is psi naught x alpha by pi to the power 1 by 4 e to the power minus alpha square, where alpha is m omega naught by h cross square and omega naught square defined as k by m. Which one of the following probability of finding the particle outside the classical region is allowed? Now let us discuss what do we mean by outside the classical region. We know it. This is classical potential curve, and when we plot it, psi of nx, psi nx for large n, this curve resembled, quantum mechanical curve resembled this curve is for quantum mechanics. Mechanical curve. For large N. Now, so this region are not classically allowed. So, in this problem, question is asking probability of finding the particle outside classical region. Now, let us assume turning point is A0 and minus A0. So, effectively my probability would be, in both the region would be, since symmetry is there, I can write it down. Probability outside classical region twice A0 to infinity mod psi of x square dx. Now this A0 is determined by equating E with the potential energy. So E is half m omega square A square is equals to 1 by 2 h cross omega. So the value of A is turning out to be root over h cross by m omega. Now, further, psi 0x, so psi 0x is defined as alpha by pi की power 1 by 4 pi minus alpha x square, and alpha was defined as m omega by h cross. M omega naught by h cross. So we can take it m omega naught. Substituting these value in above equation, we would be having it 3x greater than a0 is equals to twice alpha by pi की power 1 by 2 a0 to infinity e की power here it was divided by 2 e की power minus alpha x square into dx. I am assuming m omega h cross x square is equals to y square. So x would be h cross m omega की power 1 by 2 y, and dx would be h cross m omega की power 1 by 2 dy. Now using these value change, using change of variable method, we would be having 2 alpha, that means m omega 0 by h cut pi की power 1 by 2. Here we would be having h cross m omega naught 1 by 2. Now, when we just focus on limit as of now, just focused, take the limit as it is, we will change it next second. Minus y square dy. So Our probability x greater than a0 turned out to be 2 by root pi a0 to infinity e की power minus y square dy. Now, let us here know this when we change the variable, our limit should have changed. So I am writing here instead of a0 as y0. So let us determine the value of y0. Y square was defined as x square into m omega naught by h cross. And when x approaches a0, y0 tends to a square omega naught m by h cut square, h cut, and a was having value h cross m omega 0 into m omega 0 by h cross. That means y approaches 1. So when h approaches a0, y approaches 1. When x approaches infinity, y approaches infinity. Substituting this value in this result, px greater than a0 is 2 by root pi 1 infinity e की power minus y square dy. The effective number while you solved it out, this integration is 83.3% of, sorry, it's turning out to be 16.7%. And for px less than a0 would turn out to be 83.3%. So probability of finding the particle inside the classical limit would always be 83.3% and outside that is 16.7%. This is, you always remember. So our correct answer would be B. I'm writing here again px less than a0 or probability inside classical oscillator is always 83.3% and probability outside classical operator or classical oscillator is 16.7%. A linear operator acts on two orthonormal states of a system psi1 and psi2. Psi1 operator O operate on psi1 in such a manner, that is, if O operate on psi1 we get psi2, and if O operate on psi2 we got 1 by root 2 psi1 plus psi2. The system is in superposed state defined by psi. So we are having psi. We just write it on the next slide. Defined by psi, we have to determine expectation value of O in state psi. Now let us write first the psi. Psi is 1 by root 2 psi1 plus I by root 2 psi2. Operation on O on psi1 is equals to psi2 and operation on O on psi2 is equals to 1 by root 2 psi1 plus psi2. Now applying operator O on psi, we get one by root 2 on psi 1 plus I by root 2 O on psi 2. Using this value, we get result 1 by root 2 psi 2 plus I by root 2 1 by root 2 straight psi 1 plus psi 2. So our result will be 1 by root 2 psi 2 plus I by 2 psi 1 plus I by 2 psi 2. Now clubbing the equation together, I by 2 psi 1 plus 1 by 2 plus 1 by root 2 plus I by 2 psi 2. Now multiplying with bra in equation, let us take it 1. So when I multiply it, we get expectation value of O psi O cap psi cap. Now we would be having I by 2 1 by root 2 psi 1 with psi 1 plus I by root 2 1 by root 2 plus I by 2 into psi 2 dot psi 2. So here we would be having it I by 2 root 2 plus here we would be having it I by 2 minus 1 by 2. So we can combine this result. Let us check the first option. Option is given in terms of 1 by 2 root 2. So let us combine it. 1 by 2 root 2 is common. So we would be having it I root 2 plus 1 minus root 2. Here there would be 2 root 2. So this term, so here would be minus 1. Let us check the option. I root 2. In this problem, we have made one mistake. I have taken I by root 2, so bra would be minus of I by root 2. So that was a mistake. Here it would be minus, this would be plus. We would get minus root 2 plus 1. And this can be written as 1 by 2 root 2 1 minus root 2 minus 1 iota. And this is similar to option D. Hence option D is correct answer. Consider a one-dimensional infinite potential well of width A. The system contains 5 non-interacting electrons, each of mass m, at temperature T0. The energy of highest occupied state is. So energy inside an infinite box is En is equals to n square pi square h square by twice ma square. We are having 5 electrons which are to be distributed. Now since electrons are fermions, they can n is equals to 1, n is equals to 2, n is equals to 3. 5 electrons, 2 would occupy it in n is equals to 1, 2 would occupy it in n is equals to 2, and 1 would occupy it in n is equals to 3. So the energy corresponding to highest occupied state is E3 corresponds to 3 square pi square h square by 2 ma square, that is 9 pi square h square by 2 ma square. In this question, two relative particles with opposite velocities P1, P2, V minus V collide head-on and come to rest by sticking together. That means that is a finite scenario. Which of the following quantities is or are conserved? So in such type of collision, total energy and total momentum is always conserved. So correct options are A and B. In a Compton scattering experiment, the wavelength of incident X-ray is 0.5 angstrom. If the Compton wavelength delta C is 0.024, the value of longest possible wavelength for the scattered X-ray is, according to Compton relation, we have lambda dash is equals to lambda plus lambda c 1 minus cos theta. Maximum for maximum wavelength, cos theta should be equals to cos pi equals to minus 1. In that case, lambda dot maximum would be lambda plus lambda c 1 minus cos pi, which equals to lambda plus lambda c 1 minus minus 1 equals to lambda plus 2 lambda c. Now substituting this value, 0.50 angstrom plus 0.024 angstrom into 2. So result would be 0.500 plus 0.4048 angstrom, and wavelength will be 0.548 angstrom. That would be lambda maximum. The radioactive nuclei K40 decays to AR having half-life T1 by 2 equals to 1.25 10⁹ year. The isotropic ratio for the particular rock is found to be, that is, N of K40. In better form we can write this one. N of 40K divided by N of 40 AR is equals to 50. The age of rock is, time period would be m into 10⁷ if we solved it. Then what is the value of m? That is the question. Now let N0 be the original number of atom of nuclei 40K. So after time t, number of N K40 is given by N K40 would be N0 minus lambda t. Number of of 40 AR in number of atom in nuclei 40 AR is now, and 40 AR is N0 minus number of N into 40K, जितना उसमें decay होगा. We just reduce the number of decaying particle of 40K. That would be N0 minus N0 e⁻ minus lambda t. According to question, we have N 40K by N 40 AR equals to N0 e⁻ minus lambda t divided by N0 minus N0 e⁻ minus lambda t is equals to 50. Implies 1 minus e⁻ minus lambda t divided by e⁻ minus lambda t is equals to 1 by 50, or 1 by e⁻ minus lambda t minus 1 is equals to 1 by 50 plus e⁻ lambda t is equals to 51 by 50, that is 1.02, or t would be 1 by lambda ln 1.02. So value of lambda would be 0.693. Lifetime is 1.25 10 to the power 9 year. Ln 1.02. When we solve this value, that turned out to 3.57 to the power 7 years. So this can be written as m into 10 to the power 7 years. The value of m is 3.57. So the value of here is 3.57.